So today we're going to do a few examples going over how to manipulate decimals for addition, subtraction, multiplication, and division. Okay, let's go ahead and start with addition and subtraction because they're actually the same. So let's say we have a number like 347.56 plus 0.73. Okay, doesn't matter. The point is to line up your points because in addition and subtraction, you line up your decimal points and you drop it on your answer. It really is the first thing you do. And after that, you guys know how to add. Sometimes you carry, sometimes you don't. 6 plus 3 is 9. 5 plus 7 is 12. Put the 2 down. Carry the 1. 1 plus 7 plus 0 is 8. There's nothing here, so we just drop the 4 and the 3. Very similarly to addition is what we do in subtraction, okay? Let's say we have 5.637, and then we're going to subtract that from 0.765. Again, our decimal points are lined up. So I drop my decimal point. First thing I do. And after that, because I'm subtracting, right? Now I have to ask myself, is the number on top bigger or smaller? Do I need to borrow? Okay? That's where our mindset has to be. 5 or 7 minus 5 is 2. 3 minus 6, nope. 3 is too small. The 3 borrows from the 6. This 6 becomes a 5. This 3 becomes a 13. 13 minus 6, 7. 5 minus 7, nope. 5's too small. So this 5 borrows from its neighbor, the other 5. This 5 becomes a 4. This 5 a 15. 15 minus 7 is 8. And here, now we have a 4. We used to have a 5. Now we have a 4. 4 minus 0 still gives me 4. Okay, so in those two examples that you just saw, we can see that all we had to do is line up the decimal point and do the math that we've been doing since what? Second, third grade, right? You borrow when you need to borrow. And then you don't borrow when you don't need to borrow, right? And when you're adding, sometimes you carry, right? If the number is 10 or bigger, you have to carry. And sometimes you don't have to carry, right? Just make sure you line up your decimal and then put the decimal point straight down, okay? Now let's move on to multiplication. Here's my little squiggle line. Let's do multiplication. Let's say we have a number like 5.63 times 7.7. Let's make it easy. So with multiplication, we take a different strategy. We actually ignore the decimal point. We ignore the decimal point completely for now. And what we do is we set up our lattice boxes. Now we know that we're going to need 3 columns and 2 rows. Okay, so let's go ahead and draw that out. Okay, here are our 3 columns. 1 for each number, right? 1 for the 5, 1 for the 6, and 1 for the 3. And now we need 2 rows. Oops, it came out lopsided. That's okay. 1 for the first 7 right here, and then for the second 7 down here. Okay, let me try to see if I can do my diagonals because my boxes are kind of crazy looking. Yep, it works though. All right. So these 2 boxes, or this row and this row, are going to have the same numbers because we have a 7 here and a 7 here. So 7 times 3, 21. And I still know that 7 times 3 is 21. So I'll do it down here also. 7 times 6 is 42. Same at the bottom. 42. 7 times 5, 35, and 35. So now all I have to do is add, right? I always start with my right-hand side. 1 plus nothing is 1. 1 plus 2 plus... plus, yeah, 1 plus 2 plus 2 is 5. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 5 is 13. 3. Carry the 1. 4 plus 1 is 5. 5 plus 5 is 10. 10 plus 3 is 13. 3. Carry the 1. 1 plus 3 is 4. Okay, so now that I have my answer, I'll write it up here. 4, 3, 3, 5, 1. Now we can see how the decimal point plays into all of this. Let me count my spaces. 1, 2, 3. There are a total of 3 decimal places. So I have to use that with my answer. There's an imaginary decimal at the end, and just like I counted 3 here, total, right? 1, 2, 3. I have to do the same thing here. 1, 2, 3. And that's the home of my new decimal point. So when I rewrite my answer, 43.351. Okay? And that's my answer. So now we've done addition, subtraction, which are honestly the same process. And now I showed you an example of multiplication. Okay? The next one here is division. So when I write a division problem, right? Let's say I have, 5.2 on the outside. And on the inside, I got, let's say, 17.032. Okay. If we have a number like this, the first thing is I have to notice I cannot have a decimal point on the outside. I cannot. So I know in multiplication, we kind of ignored the decimal point was there. With addition and subtraction, we had to line our decimal points up. In this case, I cannot ignore the decimal point. And right now, I cannot line it up. I have to get this guy out. So I have to see how many times do I need to move it over to make it a whole number. So I have to move this decimal point only once. But whatever I do on the outside, I have to do on the inside. So since I move this over once, I'm going to move this over once. And that's the home of my new decimal point. So, and let me draw another squiggly line here to separate it. When I rewrite the problem, it's 52 on the outside. And then 170, that's where my new decimal point goes, 32. So now that I've moved my decimal from the outside, now that I've moved my decimal one more space on the inside, now I can line up my decimals. I have a student that says clone. That makes sense as well. I do that even before I start dividing, even before. So that way I don't forget it. Now I ask myself, can 52 go into 1? Nope. Can 52 go into 17? Nope. But can 52 go into 170? Absolutely. Let's see how many times. 52, and I'm going to multiply it times a number. Hold on a second. There we go. I'm going to take a guess. I'm going to say 3. Oh, my pen is failing me. Hold on a second. Time to get a new one. Okay, let's say times 3. That's my guess. So 2 times 3 is 6. 0, 6. 3 times 5, 15, right? So let me do my adding. 6 plus 0, or 6 plus nothing is 6. 0 plus 5 is 5, and then I got a 1 right here. Okay, so my answer is 156. And that's pretty close to 170. I don't think I could fit another 52 in there. So I'm going to go with 3. So above the 0, right, I put a 3. And I already know that 3 times 52 is 156 because I already did the math. So I put 156 underneath. And now I do my subtraction. The 0 borrows from the 7 and becomes a 6. This 0 becomes a 10. 10 minus 6 is 4. I have 6 minus 5 is 1. And then I have 1 minus 1, which is 0. So I don't need to write it. Now I'm going to drop my 3. And now it's like I got a new division problem. Because now I got to ask myself, if I divide 52 into 143, how many times can it fit? Well, I know that 52 times 3 is 156. And that's bigger than 143, but not by much. So what I'm going to do is 52 times 2. Okay? Oh, let me use my squares. 52 times 2, 0, 4, and 10. Right? So 4, 0, 1. So I'm going to put a 2, because that's what I used here, right? Right there. And I already know that 2 times 52 is 104. Now I can subtract. 3 minus 4, can't do it, I have to borrow. This 4 becomes a 3, this 3 a 13. Now I can do it. 13 minus 4, 9. 3 minus 0, 3. 1 minus 1, nothing. So what do I do next? I drop a 2. Now I have to ask myself, how many times can 52 go into 392? Let me write that 3 a little darker, okay? And I do the same thing. I take a guess. I know that 52 times 3 is 156. And even if I double 156, I get close to 392. So I'm going to try 52 times 7. Now, I might go over. I might not go over. We'll see. Let me use another sheet of paper for this one. 52 times 7 is what I'm going to try. $14, 35. Now I add 4, 6, 3. So I got 364 here. And that's still not bigger than this, but I don't think I could fit another one. So 7 is a good guess. I got lucky. Sometimes you get lucky, sometimes you don't. And I already know that 7 times 52 is 364 because I already did the math. So I write 364 and then I subtract. Let's see what I get. Okay, I'm going to borrow again because the 2 is smaller than the 4. That becomes an 8. This becomes a 12. Now I can subtract. 12 minus 4 is 8. And you might not be able to see the bottom numbers, but you can hear me. 8 minus 6 is 2. And 3 minus 3 is 0. So I have 28 left over. Okay, let me see if I can move it up a little bit so you can see it. Okay, I think you can see it now. So I have a 28 left over. But I'm out of numbers. So what do I do? Well, this is when we add a 0 at the end. Whenever you have a remainder and you're doing division with decimals, we have an option of adding a 0 and dropping it down so 28 turns into 280. And then we keep dividing until we have no remainders left. Okay? So I'm not going to finish this problem because it'll go the same way. 52 into 280. I take my best guess. And then after that, if I still have a remainder, guess what? I add another 0. Okay? Now with the problems you guys are working with, likely you will not have to add too many zeros. but just know that that is an option, okay? So hopefully you understood this, all right? Let me know if you have any questions later. Take care, guys.